Okay, so now I'm going to continue where we left off. I'm going to try to find an error bound for this remainder, something that bounds this remainder. So if we have a function, f of x, which is continuous, positive, decreasing, and f of n equals an. It means it matches the sequence inside parts on all the integer numbers. Okay? So, and now this only works for sequences, series whose inner parts of sequences are positive. Let's look at an integral. Integral is going to help us here. It's going to be kind of like the integral test. Let's look at a n and then a n plus 1 and sorry, let me erase this. It's not what I meant. I'm going to look at n plus 1, n plus 2, and we're going to take this function on it. So when we plug n into this function, we're going to get an. When I take n plus 1 in this function, I'm going to get an plus 1. When I put a2 and n2 into the function, I'm going to get an plus 2. And so we're going to get a decreasing function. And let's look at the size of these boxes. Let's look at this box. Look at this box. And if I went out to n plus 3, what's the size of that box going to be? And so on. Okay, how big is this box? Well, how tall is it? Its height is going to be an plus 1. So the size of that box, width of 1, height of an plus 1, so the size of that box is going to be an plus 1. What's the size of that box going to be? That's going to be an plus 2. Size of that box, an plus 3. Now if I added all these boxes up, what we know about the addition of all these boxes in the area underneath this curve from n to infinity. Which one's bigger? The integral, the area, has got this much more area. It's actually, the integral of this function is going to give you this whole area, but it's bigger than it by this much. So what do we know? We know that the integral, the summation, so what's Rn? Rn is going to be, that's an plus 1 plus an plus 2 plus an plus 3 plus out forever. But we know that that's going to be less than the integral from 1 to infinity of f of x dx. So what do we know? Is that a remainder term, if we have a remainder term, and we can find, if we have a remainder term, and we can find the function that's continuous, positive, decreasing, and matches the sequence at the integer points, then we know that the remainder is less than the integral from n to infinity of f of x dx, and that allow us to get an upper bound for error. And we can tell our boss, use this answer and you won't be any more wrong than this much, whatever this guy is. I'm going to stop this video and then I'll do another one here with an example.